Having seen a couple of non-deterministic and deterministic finite automatons, let us understand the power of non-determinism. There are many case studies where constructing a non-deterministic finite automaton is rather straightforward compared to constructing a deterministic finite automaton. So what we do, we exploit non-determinism and construct a non-deterministic finite automaton, then use subset construction to obtain an equivalent deterministic finite automaton. For example, let's look at this language consisting of set of strings, say over 0, 1, such that 10th symbol from the right is 1. So if you look at any x in L1, it is having this property, 10th symbol from the right is 1. So which means, for example, suppose 1 followed by say 4 0 followed by 5 ones. So 5, 4, 9, 10th. So 10th symbol from the right is 1. This is one string, or it could be 0 0 1 followed by 1 1 1 0 0 0 1 1 1. That's all. So 9 followed by 10th symbol from the right is 1. So like this one can list many strings over here. Now it clearly tells you that the pattern that we are looking for is something like this. So you have 1, and let's look at the other 9 digits. This could be 0 or 1, this could be 0 or 1, this could be 0 or 1. So like that, this could be 0 or 1. So let me call this one as digit number 1, digit number 2, so on up to digit number 9, and digit number 10 from the right is 1, and to the left of this it could be any x prime over 0 1 star. So if you go for a deterministic mission will not explicitly tell you that this is the number of digits or this is the length of the string and so on, right? So somehow we should remember all of this information. Unless I remember all of this, I won't be able to say that 10th digit from the right is 1. Okay? But if you allow non-determinism, meaning some form of guessing, assuming the current digit is 1, and then you start exploring the rest. So if you bring some amount of non-determinism, then constructing an automaton is relatively easy. So let's try building an automaton out of this picture. So what this says is the following. First part is, it could be any string over 0, 1. Then somewhere the guessing happens whether I should loop on this part or maybe I've started seeing the pattern. So 10th digit is this, then 9th digit is 0 or 1, so it could be 0 or 1. For both of them I go to this state, then again 0 or 1, then again 0 or 1, then again 0 or 1, then 0, 1, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8, if you count from this would be D1, D2, D3, D4, D5, D6, D7, D8, D9, D10 is 1. The prefix could be any combination of 0, 1. Now, if this is your start state, then delta of Q0, 1 says Q0 as well as Q1. So this is clearly a non-deterministic finite automaton accepting the pattern this. Now when you try constructing a deterministic mission out of this, so unless we remember this, that we have seen so much, out of that 10th symbol from the right is 1, we won't be able to get a deterministic mission. But for a non-deterministic mission, you have this advantage. So somewhere when you scan the string, you are guessing, should I loop over 0, 1 and stay at Q0 itself, or should I go to Q1 for the current one? And one branch will loop on Q0, another branch will go here, but the automaton says if at least one branch takes you to the final state, you say accept. So this kind of guessing helps you to discover at least one accepting path, but whereas the guessing is not allowed as far as the deterministic mission is concerned. So which means one has to remember all of this information about the last 10 symbols read to say so and so string is part of this language or not. So this is one classical language where the power of non-determinism is exploited to a great extent in building or designing an automaton. So the power of non-determinism is simplifying our design, and subsequently an equivalent non-deterministic mission can be obtained using a subset construction. So all this is just like a tool and helping us to come up with the design in quick time. There are a couple of other case studies which we shall see next. So consider this language. What it says is set of strings x belonging to 0, 1 star such that there are two zeros in x that are separated by some number of symbols, that are separated by number of symbols that is a multiple of some digit, say 4. So what it says is, you look at x, that x has this property. Somewhere there are two zeros in x and something like 0, 1, 0, 1, 1, 1. So there are two zeros in x, and if you look at them and look at the number of digits separating them, number of symbols. So number of symbols that is separating them, that is a multiple of 4. 0, in this case 0 number of symbols are separating these two because they are consecutive, and 0 is a multiple of 4. Or it could be 0, 1, 1, 0 followed by 0, 1, 0, 1, then 0 followed by 1, 1. So if you look at this 0 and this 0, it only says there exist two zeros and they are separated by number of symbols that number is a multiple of 4. They are separated by number of symbols, that is a multiple of 4. Okay, so, or it could be like 0, 1, 0, 1, 1, 1, 0, 0, 0, followed by 0, 1, 0, 1. So, somewhere the 0 starts and ends. In between, if you count the number of symbols, and symbols are 0 and 1. The number of symbols is a multiple of 4. Prefix of that and suffix of that could be any string over 0, 1. Okay, so this could be any string over 0, 1. This could be any string over 0, 1. This could also be any string over 0, 1. But only condition is string length is a multiple of 4. Okay. So let us try drawing this picture into an automaton. So to start with, it says it could be any string of 0, 1. And the simplest possible pattern is 0 followed by a 0 followed by any string over 0, 1. And or between these two you may see some number of symbols which are multiple of 4. So that could be, this could be 0, 1, this could be 0, 1, this could be 0, 1, this could be 0, 1. So either you go directly here without getting into this loop, and in that case you get a prefix 0, 0 followed by a suffix, or prefix 0 followed by 1, 2, 3, 4. You want to go through the cycle again, 5, 6, 7, 8, 9, 10, 11, 12. So every time you go through this cycle, you see that you would have seen number of symbols which is a multiple of 4. Then you exit. If you exit, you get to see that between these two zeros you have seen a pattern, and if you count the number of symbols in it, that will be multiple of 4. Okay, so each symbol could be 0, 1. It could be 0, 1, 0, 1, 0, 1, and prefix and suffix could be anything. Here again we are exploiting the power of non-determinism, because we are guessing. It may so happen that you may go over Q0 itself for the entire string, and the moment you see a 0, you may think probably this is the first 0, and as part of our pattern, then you go through this cycle, and this would be our second 0 as part of the pattern. Or you may see a part of this until this, then you may go through the rest over this. That can also happen. Or you may go through a part of this and the rest over here, and you may get stuck. But all that we want is, if there exists at least one sequence of transitions starting from start state to the final state having this pattern, then this automaton clearly accepts and stop the machine. So now this tells you that constructing a deterministic finite automaton is not straightforward, whereas a non-deterministic machine is relatively easy and straightforward. And so here is the second case study where the tool non-determinism has been exploited to a great extent in coming up with a design for this case study. Let's look at one more. Here is our next case study. set of x such that x is over 0, 1, 2, 3. The property is the following. If you look at the x, so x over 0, 1, 2, 3 star such that the final digit or symbol appeared before. So what does it say? You look at x and suppose the final symbol is 3, somewhere else 3 must have appeared in the string. This is an example. Suppose the final digit is 1, then somewhere else we should find 1, not just one time, maybe many times, something like this as well. Similarly, if the final digit is 2, somewhere before we should see 2. It could even be 2, 2, 2 everywhere. Okay. In that case, it is immediate, or you can take for this 2 any 2 from this. So if you look at the final digit, it must have appeared somewhere else in the string. Okay. Now, possibilities for the final digit are if it is 3, somewhere else we should see 3. Before that, it could be any string over this. Similarly, between also it could be any string over 0, 1, 2, 3 star. And on the similar line, what if it is 2? What if it is 1? What if it is 0? So between these two and before this 2, it could be any string over this alphabet. It only says this digit must have appeared somewhere. It is not telling you the position, and it is not telling you the number of symbols that is separating these two. Should there be any constraint? No. And can this digit appear more than once? Answer is yes. Okay. So keeping all this, let's design a mission. So we say that to start with, we read 0, 1, 2, 3. Then we may see 0 followed by 0. This will be our last digit. In between, we may see 0, 1, 2, 3. Or we may see a 1 and see another 1. In between, we may see 0, 1, 2, 3. Or we may see 2 followed by a 2. In between, 0, 1, 2, 3. Or we may see a 3 followed by a 3. In between, 0, 1, 2, 3. Now this clearly tells you that the pattern 3, 3 or 2, 2, 1, 1, 0, 0, and prefix could be anything, that is taken care by this. Now after seeing a 0, you may see some string over 0, 1, 2, 3, that is taken care by this mission. Now when you read a 0, we go to Q0 as well as this state Q1. Similarly, when you read a 0 over here, we stay at Q1 as well as we go to this state. And some amount of non-determinism is exploited because the mission is guessing, should I stay here, or assuming this is the 0 that is part of the pattern, should I move along this direction? Correct? But so on the similar line, should I stay here and take this path for 1 1 or 2 2 or 3 3? So this is another case study where non-determinism is helping us in designing an automaton. Subsequently, an equivalent DFA can be obtained using subset construction. So like this, there are other features that one can associate with finite automaton, which will help us in designing finite state automaton. And as always, there is a procedure to convert from a new framework to a deterministic finite automaton. So in some sense, one can always obtain a deterministic finite automaton starting from this framework. Okay, so let's explore other features.